Why don't you tell me a little bit about who you are?
Well, I'm a writer. I'm based in Alaska. I have written a lot about science, environment, things that are on Earth, and got together with Amanda to write about something that was like way beyond anything that I had ever written about. Although it turns out that there's a lot about space colonization that you can learn about from Earth colonization, and I had written quite a bit about that.
I'm Amanda Hendricks, and I'm a planetary scientist, and I study mostly moons in the solar system, including Earth's moon and the moons of Jupiter and Saturn. I'm active on the Cassini mission, which is in orbit at Saturn, and it's coming to a close, sadly, this year, but it's been a big part of my life for the last nearly 20 years.
It's hard to imagine it not.
I know, it's really
sad.
But I worked on the Galileo mission at Jupiter also, and I work on the LRO mission in orbit at the moon, and so it's just really fun. I love studying moons and small bodies in the solar system and what they're made out of and how they're evolving and what their histories are.
So how did this book come about?
Right, so we were introduced by a literary agent who thought we would be a good team to write a book about space colonization. And so we thought about it and put our heads together for about a year, getting our concept together, and we decided together that we wanted to make a book that was as factually based as possible. We did not want it to be sci-fi or fantasy land type of book at all. And so we had a lot of fun, talking about how we were going to put this all together and how we were going to do it. It was a lot of work, and it took us about 4 years in all to do it, but I think we put together something really good and interesting.
One of the aspects of having the sort of this joint project is our having to sort of meld our different personalities and outlooks. In that Amanda's the big time tech enthusiast, and and has got a very optimistic view of science and space, and I've written more about the environment, and I tend to be more skeptical and less excited about that stuff. So I think what happened is it allowed us to come to some agreements that give a really good balance to the outlook of the book, that it's not just sort of starry-eyed enthusiasm, but it's also not super pessimistic in the end.
Why don't you describe its basic premise?
It's a book about space colonization, and it's about all the issues surrounding how we can make that happen, under the assumption that we're sending humans to the outer solar system. And the reason is that, and we spend a lot of time going through why this destination in the outer solar system, which is Titan, the moon of Saturn, is the best place in the solar system for humans to set up a long-term, self-sustaining colony. We talk a lot about why we even want to set up a colony elsewhere in the solar system. And we set up a scenario for, in reality, why that would actually happen. And all of the issues about how we need to make it happen, and the hurdles that we need to overcome. There's a lot of medical issues that need to be resolved with how humans can survive in microgravity and in the radiation environment in particular. And propulsion is a big thing. How are we going to get to these places in the solar system fast enough that humans can survive it? And why Titan? We talk a lot about why Titan is actually the best place in the solar system. A lot of people think about Mars, and Mars is where NASA is currently planning on sending humans, and that's great as a stepping stone, but it's actually not the best place for a long-term settlement by any means. There's a lot of issues that we talk about. Who would be the right crew to go on the first mission? How would you actually consider setting up, a new society on Titan? And where's it going to go in the future? And, we're talking generations in the future. It's going to be a whole new cultures, and how is that going to work? And how are people even going to look in growing up in that microgravity environment and, in a whole different world? So a lot of interesting philosophical and ethical issues, I think.
Well, I think one of the things that we did in developing this was try to constrain what the scenario we're developing by what we saw as the realities, which is that people aren't going to build colonies in space for absolutely no reason. It's going to be a really expensive and challenging thing to do. And so you have to think about, what are the barriers to doing it? what are the costs, and then what are the drivers. And to do that, we sort of tried to think about like why would people want to do this, and what kinds of planets would that rule out, And so we sort of, a lot of focus has been put on Mars, and we just couldn't really come up with any reason why people would go to Mars and live underground. The reasons that would drive you to do that, you could kind of live underground on Earth if you're worried about, something horrendous happening on Earth. But developing these constraints, and then a forward scenario, we were trying to create sort of a thought experiment that the reader could run in their own mind and say, yeah, I could see why that really would happen, or maybe you disagree, and you can pick our argument apart. But it's in that way we're trying to make something that's that they will carry, that the reader can sort of go along with or not go along with, and it's going to be more interesting than just speculation.
Okay. You said there's a lot of disadvantages to Mars. Do you want to name a few?
I'll start.
Okay.
The number one disadvantage is, because there are some advantages, and let me start with the advantage. I'll be positive. It's relatively close. And that's, I think, probably one of the main reasons why we're talking about going there now. It's relatively accessible. I won't mention that we haven't left low Earth orbit in decades. So it's not that accessible, obviously, but hopefully we'll get there. But it is relatively close. But it doesn't have much of an atmosphere, and that's the main showstopper. It's got a thin atmosphere, no magnetosphere, and so that's why Charles mentioned that if you go there and live there for any period of time, you're going to have to live underground, because you're going to have shielding from all the radiation. That's very damaging. And if you're going to go live somewhere else, I don't understand why you'd want to go and live underground. It's not really an advantage. But as I said, it is important for us to get past low Earth orbit and to get somewhere so we can keep moving forward with humans in space. That is important. So we do need to get to Mars, and we do need to use it as a stepping stone to better and more places in the solar system.
Considering Titan's environment, incredibly thick atmosphere, not a lot of sunlight reaches the surface, and you would have to be, enclosed the vast majority of the time. So how does that differ from being underground?
Oh, okay. Well, there's a few things. The thick atmosphere is a real advantage in lots of ways, but the number one way in my mind is that it's a shield from all that damaging radiation. So you don't have to live underground. It is darkish there. It's not completely dark by any means. I've heard it compared to a few minutes after sunset on Earth. So pretty fine, I think. And it is very cold. But the nice thick atmosphere means that you don't have to wear a pressure suit. So all you'd have to wear when you go outside is something to keep you warm and something to help you breathe, because even though there's a thick atmosphere, there's no oxygen. So really manageable, I think. Lots of resources to make buildings and to heat them and to light them. So yeah, you'd be living indoors, but you can certainly go outside. And there's lots of recreational activities.
Such as?
Such as boating. And flying in the atmosphere. You could fly around on an airplane, or you can fly around with wings strapped onto your arms, because the gravity is low and the density is thick, air density.
And just to continue that comparison of Titan and Mars, on Mars you're living essentially permanently underground, and so if you're expanding your habitat, you're doing some huge excavation work for everything you want to do. On Titan, you've got these hydrocarbons that are more than abundant; they're just ubiquitous, and so you've got materials to make plastics to any degree, and so you could build big inflatable buildings as large as you want, and you can burn the fuel there to create energy that will heat and inflate those buildings. And so you've got the opportunity for big indoor warm spaces, which I think as human beings we're going to want. I just think that to think of us burrowing around underground on another planet as a permanent habitation just kind of stretches the credulity. Whereas Titan, there's this, there's obviously it's cold and it's relatively dark, but all the resources you need are there to really build a big culture, where people could actually just have a plastic extruder and just keep building and building and building.
So instead of metallurgy-based society, you view it as a polymer-based one.
Yeah, yeah.
Yeah, you obviously would need some metals, and we were positing that you'd probably mine metals from asteroids. But for the most part, you would be sort of in this plastic world.
Okay. So the metals would be brought in externally, and the rest.
There may be small amounts of metals in the interior of Titan, but I'm guessing it would be easier. It would be hard to access them. It would probably be easier to get them from the asteroid belt.
So in terms of, you mentioned this as, you could have a fuel cycle because there's water and you can get oxygen from that and so on. But how do you sort of open the cycle? Because
you need to bring along an energy source like a nuclear reactor, and that's fine. That's doable. You can, we use them on spacecraft all the time, right? And you just take one, and it lasts for decades to get you started. And there's lots of options. We talked about the hydrocarbons, but there's even other options like wind power, since there's a thick atmosphere and there are winds. And the winds get pretty high speed higher up in the atmosphere. So you could imagine a wind power station aloft, somehow tethered to the ground. Even solar power, even though it's dim there, the sun is dim because you're 10 times farther out from the Earth, from the sun, and there's a thick atmosphere that absorbs a lot of it. Still, you can set up a large solar array and generate significant power all around the globe, so it generates power all day long. So I think there's a lot of options for energy production. It's really good. We can kind of start fresh. I feel like we could, even though we can burn hydrocarbons and do other chemical reactions to make energy, maybe we can get out of that paradigm a little bit. We talk about it in the book a lot because that's what humans think about, is burning hydrocarbons. But but maybe we can start fresh.
If you've got to make the oxygen to do it, then and you've generated the electricity to do that.
Right.
That sort of changes the equation.
Right. And that's the thing is because there's no oxygen in the atmosphere, we need to get water, which is frozen, and there's plenty of it. We have to do the electrolysis to break it up so that we can have the oxygen, but also then so we could just have the water for drinking and whatnot. And we've got to go through that process anyway, so you can use the oxygen for breathing, or you can use it for combustion, or both.
One of the things that we tried to do in the book was we started out with this idea that human nature is not going to change. Science is going to change, engineering is going to change, technology is going to change, but human will probably stay the same. So we can count on them having kind of the same motivations and making a lot of the same dumb mistakes that they make now, and also doing some of the same inspiring things. But they kind of made it fun because it gave us a platform to write some satirical events happening in the far future as people are moving to another planet and they're messing up the environment on the other planet, and they are having the same issues about like corporate stuff that's happening in this other celestial body. So that was something that turned out to be a really fun part of the book, and we weren't really trying to get too hung up on being super serious about it. We know we're talking about the distant future, and things could happen the way we say or might not. And so in terms of burning fossil fuels, we've got Exxon heading out there to do their best, right? That's going to be part of the story.
Yeah, so that's, some people have suggested that an exotic form of life, Titan has the ingredients for exotic forms of life. If we find something that on another moon or planet, do you think that sort of puts it off limits to this sort of plan?
Well, that wasn't in our scenario. We took the approach that there would certainly be people who say it was off limits, but that others might not. And also, if we think about our advanced party being robots, and sort of the potential difficulty of explaining to the robots why this life form should be sacrosanct on another planet. when their mission has been to send and pioneer that planet. So, I mean, there's sort of different things going on, but we definitely did consider that. We invented our idea of what that life form would be like and how people would respond to it, and then the political issues that would pop up around that.
But we brought it out there mainly to get people thinking, and then they can think about it how they might want to, whether they agree with us or not.
So you mentioned the biggest issue with Saturn compared to Mars is the distance traveled. So how does that play out into any plans we'd have to get there?
Right. So we need a new propulsion method, don't we? I mean, I actually think we do anyway, even just for going to Mars. Okay. Right now, a Mars journey of 6 months, and then a stay of Mars on a few months, and then a return journey. It's too long. It takes too long, and it's not going to be safe.
Too long as set by the radiation exposure.
Yes, exactly. Too much radiation dosage. And so I really feel, and this is just my opinion, that NASA ought to be and other agencies and companies ought to be working together to really be working on a new propulsion technique. But certainly if we're going to Titan, we're going to need it. Because right now, it took Cassini's spacecraft 7 years to get there. So obviously if we're sending people out there using chemical propulsion and taking 7 years, that's unmanageable. So
how many gravity assists were involved in that?
And that was a few gravity assists too.
It used Earth, didn't it?
It did use Earth once. Venus, Earth, maybe twice on Earth. Now I'm getting it mixed up with Galileo, actually. I know Galileo did a Vega, of Venus, Earth gravity assist. And Cassini did Venus, Earth, I think.
Right. And so that's not a realistic
right,
prospect
for humans.
Something with people on board. So do you have any ideas on the propulsion in this? We
do. We talk about a technique that is being studied, evidently, at NASA, called a quantum thruster. But I don't think that many resources are being applied to it right now, but we think it's something that maybe could be a good option in the future and makes us hopeful that maybe there's something out there that can be used to get people there faster. The guy whose idea it is named Sonny White, and we interviewed him a couple of times. He's at JSC, and he's super brilliant and, talks about quantum particles jumping out of nowhere and using those particles as fuel.
Okay. Is this the thing that's known as the M drive? Or?
I think it's related. It's a Q drive, which I think is close to an M drive, but I'm not sure what the difference is.
All right.
I think that,
both have been in the news a little bit lately.
Right. I mean, from the bottom line, I think that we found is that there needs to be some significant investment in stretch technology that a lot of what's being thought about in terms of human space travel is just a little increment beyond what we've known how to do for quite a while. And if we really are planning to send people like long-term to other planets, even just to get to Mars safely and get back, a lot of the investment that should have taken place a long time ago hasn't, part of which is to really quantify the danger from galactic cosmic rays and figure out like how much can we really take and what do we need to do about that. And then the whole propulsion thing, that we have to have a new way of propelling spacecraft. I mean, Mars, could maybe get to with a chemical spacecraft if we deal with all these other issues, and that's pretty far out. But to go anywhere else, we'd need a completely new kind of propulsion. And so one of our thoughts in writing the book is, let's think about what our long-term goal is. Let's start thinking about where we really want to go a couple of generations from now so we can start focusing on that technology development, because the way we're doing it now is not working. We're not really making enough progress in dealing with these issues.
And it's certainly not going to work for anywhere beyond Mars. Mm-hmm. So maybe we'll get to Mars. And then what? Are we going to have to wait 50 or 100 years till we are ready to go somewhere else? Let's not get to that point, that sort of post-Apollo point where nothing happened then for decades, or not too much. I agree with Charles that we have a much longer term goal that we're shooting towards, and have Mars be a stepping stone and use everything that we do to advance toward that long term goal.
And the panels have studied, the success or failure of NASA's manned space efforts have really come to that conclusion. Like, what is our goal? Why are we doing this? Because a lot of the goals that are often held out there really don't make any sense. That by the time we're able to do it, like robots are probably going to be able to do the vast majority of what we can do to get even on Mars. Is it for technology development? Is it for like inspiring kids? Well, there might be really less expensive ways to do that. But then everybody, I think, feels like, no, we don't want to be stuck on this planet. We want to reach out to other planets eventually. And it's a long, far off goal. But if that's our real goal, let's like enunciate that and figure out how to invest in it, how to do the research, and how to sort of get there rather than sort of incrementally trying towards things that are not the real goal that we all care about.
Does Saturn not have the same sort of levels of radiation in the environment that Jupiter has?
It's less.
Okay.
Jupiter is super intense, and Saturn's less. But again, that magnetosphere that Saturn has actually helps shield from some of the galactic cosmic rays, and the thick atmosphere of Titan helps shield from Saturn's charged particles and the galactic cosmic rays, and solar wind particles too. So it helps.
Even with the best propulsion tech, presumably the colonists there will be pretty isolated from Earth. So
right.
Do you see that as a problem? What challenges does that pose?
Well, that's why, we posit Titan as a good place, and we're not talking about coming and going and getting supplies from Earth and going back and forth on any regular time basis. We're talking about going there and staying forever. And that's one reason why Titan is really good, because it has such tremendous resources. So you don't have to keep coming back and forth or sending supply ships or something like that. So this would be a settlement that is completely self-reliant. And it's okay that Earth is far away and an hour and a half one-way light time and all that stuff for communications, because it'll be its own society. This
was one of the really fun parts about thinking about this idea of people being on Titan and never coming back is we have a lot of analogs in history, in human history, about what that's like. And so we kind of went back and studied colonies and how their cultures start to diverge from from the mother country, and we see that happening. And in this case, their physiology would change too, because you'd be in this low gravity, low light environment. And so in our scenario later in the book, we're sort of imagining what it would be like out there, and would they at some point not want any immigrants from Earth? Would they like have some big issues like with being sort of Titan nativists and that kind of thing, which again was like let us get into some of the satirical aspects of it.
Yeah, so from what I understand so far, at least, instead of what I would say is the sort of Spanish model of colonization, you're looking at something more like the Polynesian expansion, where there are outposts with a sparse bit of trade, but primarily each becomes self-sufficient, and then there's still communication and trade for centuries, but they're left to develop on their own.
Right.
So.
And also we talked in the book about how with the Polynesians, they kind of didn't know where they were going, right? They just kind of set off and hoped to find an island or someplace to go, really. And at least we know Titan is there. But it's not going to be like, oh, if we don't like it, we're going to come back. It's kind of a forever type of choice.
Assume we can get anything we want into low Earth orbit economically. Yeah. What are sort of the big challenges beyond that? You mentioned propulsion and health. Are there any others that stand out to you that we'd need to solve?
Those are pretty big.
Yeah, those are big.
I mean, we sort of like at least I didn't really understand just the severity of the challenge of the galactic cosmic rays before we started working on the book, and the fact that they're kind of like the monsters in the moat around the Earth. We don't know how to get anywhere, and the chances for shielding spacecraft, you need a couple of meters of water all the way around everybody in the whole ship. And that just seems so far out that we saw really the only solution for it is to go faster. And we did look at, we talked to people who are working on trying to develop some kind of magnet-based shielding, and people are working on artificial gravity, and all of these ideas, you end up with spacecraft that just seem like they're out of a carnival. They're just so complicated that it really seems improbable that they'll ever really fly. Whereas if you can get there a lot faster, you kind of solve a lot of issues at once. You've got an issue of how much food you can carry. You've got an issue of the radiation, and the only simple solution to all of them is a much, much faster spacecraft. So that to us, that was sort of the final thing that sort of told us that's what we're going to need before we really start moving to other planets, is a whole new generation of spacecraft.
You mentioned that you would ultimately set up this sort of primarily polymer-based economy, I guess, or resource economy on Titan. What resources does Titan not have that you'd need to get there? And more generally, as we expand into the solar system, what would need to be shipped around and what can we get locally?
The main thing that we talked about was metals, because Titan, we need the basics, right? Air, oxygen for breathing, and water, and Titan has both, indirectly anyway. So it's got the basics, but for infrastructure and building some things, we do need metals. And as I mentioned, I think it will probably be easier to get those elsewhere, and more accessible at some metallic, rich asteroids. But in terms of energy, I just kind of imagine in the future generations where new cultures have been developed on Titan, that people will develop what they need right there. And even, art forms and music and, maybe they'll be playing polymer-based guitars, I don't know. But I just think they're going to make it.
Like local computer manufacturing and everything.
Eventually, yeah.
Yeah, and by that time, who knows how much metal you'll need for a computer, right? It could be completely different. And if you've got, as long as you've got like a really abundant supply of energy, and you've got protection from radiation, and you've got this abundant supply of material to do all kinds of chemistry, you can almost just imagine it. Just about anything, right? It's easy to imagine a self-sufficient colony in those circumstances, if you can get people there, and if you can get the thing going, and sort of meet the threshold that we can't meet now, which is sort of the travel problem.
So you do seem to think that there will be some sort of organized asteroid mining and sending some resources around in your future solar system.
We didn't get into it in any depth, but we kind of figured that we can't. We're just assuming that you're going to need some metal, and if you do need metal, it's going to be hard to find in the outer solar system. So we didn't get tremendously farther into that, although we did think about that prospecting would probably be a lot like prospecting is on Earth. Somebody's going to fly around until they find a promising asteroid and then sell it to some big company, right? That would be able to mine it, or even move the whole darn thing to Titan and then mine it there.
But it's non-trivial, because the asteroid belt is really big, and there's a lot more space than asteroids in it, right? So it's hard to have that. We didn't set it up as, we'll just stop in the asteroid belt and pick one up. It's going to be a lot harder than that. So, and they won't be strategically placed necessarily when you want them, where you want them.
Yeah,
so.
It might be easier to get one of the Trojan asteroids or something.
Maybe it would be easier to get a Trojan asteroid if they're metal rich. I don't think we know just yet.
And in the original, in pretty much all colonies in the past that were sort of large, sort of industrial colonies, there's usually a ton of government support, and there's a ton of home country support that flows to the colony, and until it reaches some kind of a critical mass, and that's surely going to take place too. You wouldn't So to just show up there in your undies and just try to create a colony. You're going to go with a lot of equipment and a lot of stuff from home, and it'll be a while before it actually becomes truly self-supporting in that way.
And that's how we set it up in the book, too, where we had an initial robotic crew to get everything set up, and then an initial crew of 4 or 5 or 6 people. And then, then the ships of 100 people started coming and bringing supplies, but also bringing the settlers.
So you sort of mentioned that there might, it's not just that the locals would develop their own culture, it's that there might be cultural tensions develop over time. So you don't see humans getting past the sort of tribalism that we can't shake on Earth once we get beyond Earth.
That was one of our parameters going into this, was the idea that people are probably, human nature is not going to change. It hasn't so far. And technology makes us more powerful, but we haven't really ever gotten to the sort of the Star Trek world where we get, we go beyond war and we go beyond conflict. I mean, they're still fighting other species even in Star Trek. So it allows you to create a future scenario if you do give yourself those kinds of constraints. I mean, that was one of the things that we did, and we spent a year talking about this and figuring out how we were going to do it. And one of the things boundaries we had to put on ourselves was that we're not going to just make up anything. We're not going to, that's always the Deus Ex Machina. Well, in the future, there's going to be some technology that makes you able to do this, or there'll be some new political movement that'll solve all these problems. We just didn't want to do that because then you're just really doing an exercise in imagination, and we really wanted to do an exercise that was about science and about engineering and projecting that into the future.
You mentioned things like art and maybe music and things developing locally. How much of Earth culture do you think is shaped merely by the fact that we are on Earth, and how do you think that might change in a very alien environment like that?
Well, we thought about that a bit.
A little bit. We didn't go into it too much, but we did project some ideas about just a few kind of light concepts on how we thought some cultures might evolve and what it might be like. But it's really, that's way in the future, and it's really anybody's guess of what might happen, right? And there's probably going to be a lot of different things happening because, again, it's probably not just going to be all one culture. People are going to, Titan's pretty big. It's bigger than the moon, and so people are going to be living everywhere, and maybe there'll be the Lake District up north where people do things differently than at the dry equatorial, latitudes. I think everybody's going to be different there.
Yeah. One of the things that we did in developing our projections about what culture might be like in the future was look at the way culture developed in the American colony. The fact that, and also as when you had Europeans coming to the east coast of America, and then when you had Americans going to the west coast of America or to Alaska, there's sort of these repeating patterns where the culture in the new place is really dependent on the old place, and they're trying to copy it, and they're trying to show that they're just as good as they were back home. Meanwhile, they're creating their own history, they're starting their own historical society, they're creating their own mythology about the brave pioneers. And then after a good long time, they become confident enough that they create their own unique culture, which, in America, took really until the 20th century before we had our own music, which was jazz, which was sort of based on African music and European music, and this conglomeration became a new thing. And so it takes a really, really long time. But you can very much imagine that if people on Titan were separated by that, hour and a half of that it takes light to get from Earth, that process is going to start. They're going to start wanting to be like back on Earth and just as good as. And then eventually they're going to do their own thing, and then they're going to start defining themselves as how they're different from.
I talked a little bit about how we all sort of came of age during the Voyagers and the Challenger era. What has changed in your perception of what the outer solar system is like in that time that makes this either more or less difficult?
Oh, well, I think that Cassini has kind of changed everything, and Galileo. But the whole idea of Galileo going and orbiting Jupiter and seeing these moons and the whole system with much better eyes than Voyager was able to on its flybys. and discovering what the system was like, and discovering the probable ocean under the surface of Europa, and that as a potentially habitable world by some life form. And then Cassini, in orbit at Saturn for way longer than Galileo was at Jupiter, and learning all about that system very well. I mean, they weren't specks of light from Voyager's eyes, but they were just little round balls, those moons. And so now we understand them as worlds on their own. And each of those moons is really unique and different and doing its own thing. And, you've got Enceladus that, who would have thought it's as active as it is? I mean, we had some clues, but I think it took everybody a little bit by surprise that it's got this active plume at the South Pole. So that's really exciting. And then, of course, Titan. And thanks to the Huygens probe, we know what the surface is like, and we know a lot about what the atmospheric conditions are like, and temperature conditions, and the fact that there's not a global superficial ocean. That was the one thing that we didn't know what it was going to be like on the surface there. So the fact that Titan now, we know so much about it, and that we know it as a world, helps us to understand and really spark our imagination that we could actually go there. And we know that it is actually habitable for humans. We need to make some advances first, but I wasn't thinking pre-Cassini that we're going to find a place that's better to go than Mars, and it turns out it's way better, actually. Now, we still have a lot to do. We need to send more spacecraft back to the Saturn system to further study Titan and completely map it out in radar and in other wavelengths, and understand better what the surface is made out of, and how things change seasonally, continue to evolve seasonally. We've gotten a little bit of that with Cassini. But I think that Cassini has just been phenomenal in helping us to learn about Titan and the whole Saturn system. So it's really, to see Titan go from an orange fuzzy ball, as we saw with Voyager, to really this living world. And it is living in a lot of ways, because it's got seasonal changes and it's evolving, and maybe there's some life there. Has just been super exciting and really just a pleasure.
So those are all my questions. Is there anything I haven't brought up that you want to make sure comes across?
The only thing I don't think we talked about was commercial space. We spent a good deal of time talking about that, and the fact that it kind of changes the conversation about like what's possible, and it's really easy now to see cost of launch just plummeting, and a really rapid sort of movement of people into orbit, and then also into maybe super rapid transport around the Earth using something like the Virgin Galactic kind of spacecraft, and we see that sort of as a doorway towards what we're talking about. Adding to it like the kind of research that commercial industry is never going to do, which is sort of the big reach, the stretch to some completely new ideas.
But for any of these projects, I think going to Mars, and especially if going to Titan, they're really big, right? They're very complicated, very expensive, and no one country's agency is going to be expected to do it on its own. And we already do a lot of international collaboration with unmanned spacecraft like Cassini. So international collaboration and then public-private partnerships are really important in combining innovation and know-how to get us, literally off the ground. It's going to take a big effort.
Okay.
Great. Well, I hope you liked the book.